Hi, welcome back to my statistics class. So today we're talking about how to finding an ideal sample size. So when we talk about statistic, we're trying to find when we try to survey, right? Let's think about we're trying to survey. Let's say we're trying to find out the average height of the SPSC student. But we all know that it's impossible for us to survey every single student because that costs a lot of money and it's really hard for us to measure the hey during a certain amount of time every student will maybe respond to email or be on the campus or willing to tell us their height. So the better way to do it is we take some random sample and try to survey about them. But we also talked about that the bigger sample size that we have, then we will have a more accurate estimate, or like an estimate that closer to the true population mean, right? The true parameter. So how do we find an ideal sample size? Yes, the bigger the better, but the bigger, that means it costs more money, costs more resources. So now we can use the margin of error trying to figure out how to find the ideal sample size. So remember the margins of errors equals to the z-score times p hat q hat over n. So now let's solve for n. If you know all of the margin of error, you know the z-score, you know the p hat and q hat. Okay. So first of all, we times the z-score on both sides. No, I'm sorry, divided by. So we have margin of error divided by the z-score, the critical z-score, equals to square root of p hat q hat over n. And then we square on both sides. We have margin of error over z-score and square equals to p hat q hat over n. And then we try to solve for n by multiply n on both sides. So we have m times the parentheses things equals to p hat q hat. So we can get rid of the n. And then what? We try to divide it by the parentheses on both sides. So we have n equals to p hat q hat over margin of error over the z-score square. And now we simplify this. We have n equals to p hat q hat times, you simplify, that means you flip the fractions. We have the z-score over the margin of error square, which is this formula. If you don't remember this formula, you can just deduct it by yourself by knowing the margin of error. Okay, so here it says always round up the value of n. I'm going to tell you why later. Okay, it is believed that 25% of the adults over 50 never graduate high school, and we wish to see if the same is true among 25 to 13 years old. So in statistics, the most important thing is you use the right number to the right parameter. You match the right number to the right parameter. So we need to think about which numbers. So you need to identify which information are the useful information, which one are the distracted information. So now let's take a look. 25% was the percent usually is important, right? Because when we talk about sample distribution, what information we want to get? We want to know the proportion, p hat, and we want to know the sample size. We may want to know q hat. If we know p hat, we definitely know q hat because q hat equals to 1 minus p hat. And we want to know the z-score, right? These are the information that we're trying to get. So now 25%, we know that that's p hat. If we know p hat, we will know q hat, which is 75%. And then here it says 50 never graduate from high school. So now let's think about, does that mean 50 means the sample size? No, that 50 means just the age, over 50 years old. It's not sample size, so this is a distracted information. And here we have another number, it says 25 to 30 years old, which is the sample that we're trying to get. This is just give you the information of the sample, the people that we're trying to survey, which is not really the useful information for our statistic. This is more like a distracted information. Okay, so we still don't know n, but how many of the younger age group must be surveyed in order to estimate the proportion of non-grads within 6% with 19% of confidence? Okay, first of all, this 6% means what? Within 6%, that means this is our margin of error, is 6%. And 19% of confidence means what? What information they give you? Well, we know that each confidence interval corresponding to a certain z-score. So if it's 95% of confidence, that gives you the z-score of 1.96. 19% of confidence gives you a 1.6449, and then if it's 80%, gives you a 1.2816. Basically, here 19% gives you what? A z-score, a critical z-score, which is 1.6449. So n is something that we don't know, because they're trying to ask you how many younger age of group survey in order to estimate the proportion. This part we're trying to find out. Okay, so now we can use the formula, or you can try to find the formula by yourself. I just show you at the early of the class. So n equals to p hat q hat times the z-score over the margin of error square. So now we have all the information that we need. We just plug it in. P hat is equal to what? 0.25. Always convert this to a decimal. Times 0.75 times z-score 1.4669 over margin of error 6%, which is 0.06, and square. Okay, so now let's use a Google calculator. Divided by 0.6% and then square root equals to, here we are, so it's equal to 114.92. Okay, so remember, our n is always round up. Okay, in this case, we don't need to struggle and shit. We round up or round down, because 0.9 is always round up. Okay, first of all, this is how many people we survey in order to meet the requirement of 6% of what margin of error. So that's the least requirement. So that means we always want to get one more person. First of all, we don't have 0.9%. There's no way you can survey 0.9%. Secondly, if this is the least requirement, we need at least 114.9%. So that means in order to meet that requirement, you need to get what? 141%. So that's why you always round up. So think about it. If in order to go to get the scholarship, you need to get 3.5 GPA. That's at least, right? So that means, does it work if you got 3.4 GPA? No, it doesn't work, right? So that means you need to get at least 3.5. You can get 3.6, you can get 3.9, you can even get 3.55. but you can definitely not get 3.49 GPA to get the scholarship, right? Okay, so now here's if we want to cut the margin of error to 4%, again with 19% of confidence interval, so what would be the necessary sample size? So we want to lower the margin of error. That means we expected a bigger sample size. So again, we list all the information that we know. We have p hat equals to 0.25, q hat equals to 0.75, and margin of error. So still, oh, hold on, I'm sorry. The critical z-score, since it's also 19%, so will remain the same, 1.6449. And then margin of error, it's going to be 4%. Okay, so our n still the same formula. We plug in the number into our formula. We have 0.25 times 0.75 over 1.449 over 0.44 squared. Again, let's use the Google calculator. So here we change to 4 equals to 317.7. 300, we need to survey at least 317.7 person. Remember, that's the list requirement. So that means if you get less than this number, you're not going to attain 4% of margin of error. That means we always need to round up. So we actually need 318 person as our sample size. Okay, so that's it for this chapter. Let me know if you have other questions. I'll see you next time.